In today's lesson, I am going to describe about thiocyanate and thiocyanate ions because they have two different chemical combinations. So first, we look at the basic skeleton because both ions have the same skeleton. So here, the center atom is carbon. To carbon, sulfur, and nitrogen atoms have bonded, and also there is a negative charge. For the moment, we forget where that negative charge should go. Now, sulfur has 6 electrons in the valence shell. Carbon has 4 electrons in the valence shell. Nitrogen has 5 electrons in the valence shell. So altogether, 15 electrons. With that negative charge, it will add up to 6p. So now I am going to complete the octet of outer elements. First, we select the nitrogen atom because it is more electronegative than sulfur. Then we go to sulfur. So we have to use 16 electrons. So no lone pairs will remain on carbon. Then we can check whether the carbon has completed the octet. It has 4 electrons now. So it requires another 4 electrons. We can get that 4 electron, 2 from sulfur and 2 from nitrogen. So it will result this structure. Now we can determine where the charge is going to be. So sulfur has 6 valence shell, carbon has 4 valence shell electron, nitrogen has 5 electron. When we count the number of electrons that belong only to the sulfur atom, 4 electrons as lone pairs, and from the double bond 2 electrons belong to sulfur. That means 6 in carbon, 2 from here, 2 from here, and 4 nitrogen 6. So 0, 0, minus 1. So that minus 1 should go to nitrogen atom. Now we have to look the resonance structures because these electrons will delocalize as it permit. So there's a negative charge on nitrogen. That means extra electron. So this 2 electron can delocalize into the bonds between carbon and nitrogen. So once it delocalizes, new bond will create. So this bond has to break. Otherwise, carbon cannot keep 5 bonds. So it will result 2 electron onto the sulfur, and this becomes triple bond. And sulfur get extra electron that you have to show it has negative charge. So now we obtain 2 resonance structures. So I name this as 1, this as 2. So this again can delocalize onto the bond between sulfur and carbon, and this one of the 5 bond in the triple bond can delocalize onto nitrogen. So it will again result this one. So we have to use this reverse arrow. So then we will get to the names. So when the negative charge is on nitrogen, it is called isothiocyanate. When the negative charge is on sulfur, it is called thiocyanate. Now we will discuss the geometry of these two ions. Now, in the first one, there are two repulsion units to the center carbon and no lone pairs. So the best geometry to minimize the repulsion is linear. In the second one, also there are two repulsion units. Even though there is a triple bond, we consider them as a single unit. So again, no lone pairs. The geometry is going to be linear. So both thiocyanate and isothiocyanate have linear geometry. Now let us discuss the oxidation number. With the 1, with the 2. The structure 1, sulfur atom has no charges and it is bonded to carbon. When considering the electronegativity of sulfur and carbon, according to the Pauling scale, they are almost equal. In the Pauling scale, we can see both them are equal to 2.5. So here it is little bit tricky to determine the oxidation numbers. So now we have to think what are the most stable oxidation number for carbon. So one of the most stable oxidation number for carbon is +4. So then we have to determine sulfur withdraw its electron and get -2 oxidation, because we know sulfur usually forms compound with -2 oxidation state. When come to carbon, it is +4. The reason is nitrogen is anyway more electronegative than carbon, so it can withdraw 2 electrons from there, and with the electron that withdraw from sulfur, it add up to +4. So when we come to nitrogen, it gets 2 electrons from carbon with the extra negative charge, it -3. When we come to the structure 2, sulfur already has negative charge. So with this single bond, it withdraw 1 electron. So it gets again -2. Carbon stay +4, nitrogen -3, because there's a triple bond. From triple bond, nitrogen withdraw 3 electrons. Those 3 electrons actually they are given by carbon. So carbon peels, it loses the 3 electron. And from this side, again, it loses 1 electron. So altogether, it loses 4 electrons. That is why, say, it shows oxidation number +4. So when we go to nitrogen, it is opposite. It peels its gain extra electron. So 3 extra electron mean -3. So this is how we calculate the oxidation number for these ions. So it is little bit trickier than the previous one I have discussed. Now we will move into hybridization. When we come to sulfur, sulfur has 1 lone pair and another 2 lone pairs altogether and 1 sigma bond. So it requires 3 hybridized orbitals. So to get 3 hybridized orbitals, we can use sp2 hybridization. When we come to carbon, 2 sigma bonds, we don't consider 5 bonds. So 2 sigma bonds requires 2 hybridized orbitals. So we can use sp hybridization. When we come to nitrogen, 2 lone pairs and 1 sigma bond mean sp2 hybridization. Let us come with second one. Sulfur has 3 lone pairs and 1 sigma bond. That means sp3 hybridization. Carbon has again 2 sigma bonds, mean sp hybridization. Nitrogen has 1 lone pair and 1 sigma bond. So it means again sp hybridization.